So again, the lesson that we will be having is a package of how to do or graph the asymptote. Now yesterday we've been dealing with the vertical and horizontal asymptote. Now what we are going to do in here is we are going to combine it, mix it, and so that put them together using of course our function. Okay? Notice that when we are talking of the asymptote, we consider two asymptotes. What are these? The horizontal and we have the vertical. Okay? What are these? We have the horizontal and vertical asymptote. Notice that when we are going to have the illustration of this asymptote, we make use of an example. Okay? And our example in here is f of x is equal to 2x raised to 2 over x raised to 2 minus 4. Now, how are we going to plot or graph this function? Definitely, one way to graph the function is, of course, we see to it that we go with the always that we are going to look for the domain of the rational function. Okay? And that we have said last time that the domain of rational function will always be the real numbers, all real numbers, okay? All real numbers. Definitely, when we are talking of the rational function, there is always the exception, okay? You remember that? We always have the exception. So, what is the exception? Our exception is of course, the number that will make the denominator 0. Okay? Now, if you do not know how to look for that number that will make the denominator 0, what will you do? You just take the denominator and then equate to 0. Assuming that you do not know the number that will make the denominator 0. Again, you take the number. What is that number? The denominator, x raised to 2 minus 4 equate to 0. And then after that one, compute for the value of the x. Now, how do you compute for the value of the x? So, we have now x raised to 2 that is equated to positive 4. Extract the root because that is a square. So, meaning that is extract the root of x raised to 2. What is the root? That is the same as x. Now, what about this one?
2.
Positive and negative 2. So, meaning our domain in our rational function is all real numbers with exception. What are the exception? That is the same as positive 2 and negative 2. And so, meaning to say, if you're already having the domain, you can now consider this exception. We have said last time that the exception in the domain of the rational function will always, what is that? Represent vertical. Okay? Vertical asymptote. Okay? It will always represent the vertical asymptote of the rational function. Okay? Do you follow?
Yes.
Okay, so that is our discussion last time. Meaning, if we are going to get the asymptote of this one, we just say that the asymptote, okay, or the vertical asymptote is x. That is positive 2 and x. That is negative 2. Okay? So that is the vertical asymptote. Okay? That is the vertical asymptote. Now, of course, our focus is to graph this one. But before we are going to graph, let's try to look into the asymptote first. Okay, so we have now the asymptote that is the same as 2 and negative 2. Now, after that one, we are planning to graph this one. And so that's the time we can, we can identify now the values of x that we are going to use or evaluate, to evaluate the rational function. Okay? Now, how are we going to look for the values of x or state the values of x definitely all number, you can state all number except the exception. That is positive 2 and negative 2. Now, it is better, you can immediately visualize the values of x that you're going to use when you're going to make a plotting using your number line or using your Cartesian plane. So while I'm doing my Cartesian plane dito, gawin ko din ang Cartesian plane mo. You do your Cartesian plane. Okay? So let's try to have first the Cartesian plane or the coordinate system. So we have here, our coordinate system, let's make here, try to Now, I have in here the Cartesian plane, okay? In my Cartesian plane, I will not be completing it first, the calibration, so that I will just complete this one when I will be having now the values of y, okay? So, now what are we going to do with this Cartesian plane? We will just show the location of the vertical asymptote. And where is the location? It says in here that our asymptote is x is equal to 2 and x is equal to negative 2. So meaning to say, we'll write it down in here. So our vertical asymptote, I will make use of VA, vertical asymptote, are the following. X is equal to 2 and x is equal to negative 2. Where are those asymptote located? Of course, along the x-axis. So if we have in here the x-axis, okay, x-axis, and this must be our y-axis. The location of the vertical asymptote is in here. Ayan, this one. Okay, positive 2 and negative 2. After locating the vertical asymptote, that's the time you try to draw the line, the vertical line. Okay? So let's try to draw the vertical line, showing that this is your vertical asymptote. So we have two vertical asymptote. Ayan. So vertical asymptote, which is x is equal to positive 2. Where is the negative 2? It is located in here. So meaning, that is the same as our vertical asymptote. We'll draw it in here. So ayan. So that, of course, we cannot immediately forget. Okay, and that is the purpose. So our vertical asymptote is 2. So vertical asymptote is, of course, x is equal to negative 2. Okay? X is equal. So, what are the values of x now that we are going to use to evaluate the rational function? F of x is equal to 2x raised to 2 over x raised to 2 minus 4. Now, you can see that one. You can visualize the values of x. These values of x are along the x-axis. So, you can make use of this one. Okay? Positive 3, 4, 5, 6, and so on and so forth. So that is the values of x that you're going to use to evaluate the function. Claro? Okay. Another one is you can also make use of negative 1, 0, and positive 1. Okay? And we have negative 3, negative 4, negative 5, negative 6, and so on and so forth. These are the number that you can make use in order for you to evaluate the rational function. Okay? Do you follow? Yes. So meaning to say, all the number except the number that is that identifies or that is the value of the vertical asymptote, yun ang mga exception. Those are the exception that we do not use in evaluating rational function. Okay? Now, as I said, the purpose of having this drawing is for us to immediately identify the x that we are going to use. Okay? Now, after identifying that's the time we're going to look for the vertical asymptote. And so let's try to identify. We'll put it in here. We'll put in here the values of x. So we have in here the values of x that we are going to use. Definitely, we will base on our drawing. So let's start with, at least start with 3, okay? 3, 4, 5, 6, and so on and so forth, okay? So these are our x. Definitely, we make use of positive 1, 0, negative 1. Okay? Then, of course, let's try to continue our table in here. That is the same as the other part. We can have the negative 3, negative 4, negative 5, negative 6, and so on and so forth. So, meaning to say, these are the numbers or the values of x or the values of the domain that you can make use to evaluate the rational function. Okay? Now notice that I did not include in the values of x the exception. Okay? I did not include the negative 2 and I did not include the positive 2. Why? As I said, they are exception or they are accepted from the domain. Do you follow? Yes. So that's the reason why we did not include. Okay? Now, as I said, you can evaluate them immediately using this one. Okay? Using this one. But of course, as I told you a while back, that of course, ang focus muna natin, our focus is just to locate first the asymptotes before we're going to evaluate. Okay? Do you follow? Okay. The next thing that we're going to look into now is the horizontal asymptote. Okay? Horizontal asymptote. So, I will be there in the horizontal asymptote dito. So, I will look into the horizontal asymptote using this one. Okay? So, horizontal. Okay. I will be making use of the side for the horizontal asymptote. The vertical is in that side. Now notice that there are conditions. There are conditions that we follow in the horizontal asymptote. Okay, still remember? Now what are these conditions? Let's just try to have them. The first condition is that the n must be less than m. If your exponent in the numerator, let's copy the function in here. What is our function? Our function is f of x is equal to 2x raised to 2 over x raised to 2 minus 4. Now, notice that our n is actually the exponent of the numerator. What is our numerator? 2x raised to 2. The m is the exponent of the denominator. What is our denominator? X raised to 2 minus 4. Meaning, the exponent of our numerator is 2, which is, of course, that is the same as the denominator 2. Now notice that they are equal. They are equal. And so, we cannot make use of this condition that if your n is greater or less than m, your horizontal asymptote is equal to 0. Okay? Now, what is the next condition? It might be applicable to this one. The next condition states that if your n is equal to m, meaning to say, I will use this one. Okay, so, what is that? 2 is not less than 2. Okay? So, yan. 2 is not less than 2, and so this is not applicable. The condition number 1 is not applicable. But we have the condition number 2. N is equal to M. Notice that when we have this condition, the value of your asymptote is equal to Y. Is equal to A over B. A over B. Now, let's try to have, what are the exponent? The exponent is, what is the value of N? N is 2. What is the value of M? 2. Is it equal? Yes. So, meaning, our horizontal asymptote now, our horizontal asymptote is defined by A over B. What did we say about the A over B? The A is actually the numerical coefficient of the first term of the numerator. What is the numerical coefficient? 2. Okay? So that is the same as 2. How about the B? The B in here is the numerical coefficient of the denominator, first term of the denominator. What is the numerical coefficient? 1. And so, our horizontal asymptote now is equal to 2. Okay? That is our horizontal asymptote, meaning we are now ready to locate that one in the graph. Okay? Can we locate this one in the graph? Yes. Saan nakalocate yan? Where is that located? It is located above the point of origin. And so, I'm going now to locate that one. Let's try to locate that one doon sa point of, doon sa Cartesian plane. Okay, notice that I did not calibrate this one. We continue now to calibrate because we have already Y. Okay? We continue. So, if this is my positive 1, this is positive 2. Okay? Positive 2, positive 3, positive 4, positive 5. Okay? This is negative, negative 1, negative 2, negative 3, negative 4. So, you mark the, you calibrate by saying that is 1. This is 1. This is 2. This is 3, 4, and 5. Can we locate now the horizontal asymptote? Yes. Where is it located? It is located in here. Okay? It is located in here along the y-axis, positive y-axis. So this is our horizontal asymptote. Meaning to say, after locating now the y, which is the same as equal to 2, that we identified to be our horizontal asymptote, that's the time we're going to draw now our horizontal line. Okay? This will be now our horizontal line. Do you follow? Okay, so let's mark this one to be our, what is that? Horizontal HA asymptote, which is y is equivalent to 2. So these are the asymptotes. So how many asymptotes do we have? We have 3 asymptotes, 2 for the vertical, 1 for the horizontal. Okay? 1 for the horizontal. So, after having now this one, that's the time we're going to continue now our graphing. Did we locate the asymptote? Did we locate? Yes, we have already located. The next that we're going to do is we're going now to evaluate and graph fully the rational function. Mag-evaluate na tayo. Okay? So, in the evaluation, ibig sabihin, what is the value of our function if our x is 6? So how to do that one again? Definitely, let's try to have the evaluation. Okay? Let's evaluate by computing the, what's that? The different value of your function. So start with 6. 6. So we have what? F of 6 is equal to, what is that? 2 multiplied by 6 raised to 2. Then, where's that? 6 raised to 2 minus 4. Let's continue. This is the same as what? 6 raised to 2, 36. Multiplied by 2, 70. 72. Ayan. How about the denominator? This is the same as 36 minus 4. That is the same as 32. And then that's the time you're going to divide. So would you mind to divide? 72 divided by 32. 2.90. 25. Sorry. 25. 2.25. Okay, 2.25. That's the time we're going to place it in here. 2.25. Next, we have in here now f of 5. Okay, is equal to, again, that is 2 multiplied by 5 raised to 2. That is 5 raised to 2 minus 4. So what is that? 5 multiplied by 5, 25 multiplied by 2? 50. Okay? 50 divided by 21. So would you mind to divide? 2.38. 2.38. Okay? 2.38. Okay? 2.38. Next, the last part. The last value is negative 6. Okay? What would be the result of the function if we have negative 6? And so, if you do that one, that is 2 multiplied by the quantity negative 6 raised to the second power. Divided by 1, that is negative 6 raised to the second power minus 4. Immediately, what would be the result? Okay? What would be the result? That is the same as 2.25. 2.25. Now, that's the time we're going to fill in our table. We'll fill in our table kasi we're already done with it. So, notice that we do this one. Okay? So, we follow. Ayan yung computation natin. Ito. So, if we have negative 3, our function is 3.16. If we have negative 4, ayan, that is 2.67. 2.67. If we have negative 5, it will give you 2.38. 2.38. If we have negative 6, it will give you 2.25. Now, notice that we completed our table. That's the time we're going to plot them. Okay? I-graph natin. Okay? So when we are going to graph them, definitely one by one. Okay? Kunin natin to. Let's get this one. We bring it in there. Okay? So where is the location of 6 and 2.25? If our x is 6, ayan, if our x is 6, what must be your y? Sabi dyan, it says in there 2.25. So if this is 2.50, this must be 2.25. So where is that located? Most probably, it is located in here. Okay? We will try to draw an accurate graph. Okay? Next, if we have 5, your y is 2.38. So if this is 2.25, just above. Okay, above is 2.38. So that is if your x is 5. Okay? Ayan, so x is 5. Our y is 2.38. Okay? We do not have a very exact, okay, accurate graph, but most probably more. But of course, it will follow this one, the asymptotic style. Okay? Now notice that if we have the other one, 4, our value for the y is 2.67. If this is 2.5, the above the 2.5. Okay? So that is the location of our next point. If your x is positive 4. Now, if your x is positive 3, what would be the value of the y? 3.5. 3.60. So, 3.60, if this is your x, that is 3. How about the y? If this is 2.5, about 2.5 is 3.60. So, meaning to say, this is, if we continue that one, the graph will rise, okay? Will rise, but it will not cross the vertical asymptote. You follow? It will not cross the vertical asymptote. So let's try to show that one. So if we would like to show that one, the graph will be coming in here, and it will shift upward, but it will never cross the vertical asymptote. Okay? Do you follow?
Yes, sir.
And that is the graph. That's the graph. Another one. What about the graph of the center? What is your center? That is starting from positive 1, 0, and negative 1. Okay, notice that if our x is positive 1, the value of the y is negative 0.67. So meaning to say, that is more or less, if this is negative 0.5, negative 1, below the negative 0.5. So meaning to say, we have in here. Okay? Now, if our x is 0, it will follow that your y is 0. So meaning, we have in here. Yan. Now, if your x is negative 1, still, the value of y is negative 0.67. So it is corresponding horizontally to the other side. So meaning to say, these are the 3 points. That 3 points immediately identify what kind of the graph of this one. Meaning to say that is parabola facing downward. So meaning to say, the graph in here is, we have in here, okay? Facing downward. Facing downward. Do you follow? Oh, what do you think is the other one? Where's the location? Oh, what do you think is the other one? Oh, any volunteer? Some part. Dito. Diyan. Where? This one?
Yes, sir.
Okay, this is the one. Okay, as you can see, opposite. They are opposite in here. Okay, they are opposite. Okay, so the graph is located in here. So would you mind to plot them? Okay, I will just show them. The graph is located in here. Okay, but you plot them properly, showing the points. Okay, showing the points.